So in this video we have some conics, and we're asked to identify the type of conic we have, whether it's a ellipse, parabola, hyperbola. Don't have to graph it here. So at any time you can pause this video and see if you can work these out yourself. So let's look at the first one. As you work these out, determine not only the type of conic you have, parabola, ellipse, or hyperbola, but also determine whether it has a horizontal or vertical axis. Of course, you can identify the type of graph you have just by looking at the square terms. Do you have one? If you have just one square term, you know it's going to be a type of a parabola, horizontal or vertical axis. The first one has two square terms, one x squared and one y squared. And normally that would be an ellipse or a hyperbola, and you can tell by the minus sign. So it's a hyperbola. And I can put a 1 under this. So for the hyperbola, we know that b squared is equal to c squared minus a squared. And then we know that the a for the hyperbola, the a or the a squared is always under the term that has the positive coefficient. So that would be the x squared in this case. So you would also assume or figure out that that has a horizontal transverse axis. So c squared is going to equal to a squared, which is 25, plus b squared, and that's b squared is 1. So c will equal to, or c squared will equal to 26 here. And we take plus or minus the square root of that, and that gives us the value of c. So we know the center is 0, 0. The vertices, because it's a horizontal hyperbola, we add the value of c. A squared is 25, so a is 5. So we add the 5 to the x component. So that's plus or minus 5, and 0 would be the vertices, or 5, 0. And minus 5, 0. In the same way, the foci, the value of c is plus or minus the square root of 26, so we add that again to the x value, which of course is 0. And I'm just going to write this one as plus or minus the square root of 26 and 0. So one foci is at the square root of 26 and 0, and the other one is minus the square root of 26 and 0. And then the asymptotes are obtained by taking the standard form of the hyperbola. It's already given in standard form, and just replacing the 1 by 0 and basically solving for y. So we're going to get x squared over 25 is equal to y squared. Solve for y, take the square root of both sides. Y will equal to plus or minus, I take the square root of that, x over 5. Square root of x squared is x, square root of 25 is 5. So one asymptote is y equal x over 5, and the other one is y equal minus x over 5. So we got the center, the vertices, the foci, and the asymptotes. And of course you should recognize that a parabola only has one square term. And then you should be able to identify the type that you have. If it has the x squared, it's the vertical. The axis of symmetry is vertical. If it has the y squared, it's horizontal. The only thing we need now is to put it in the standard form. So in the standard form, we need to divide through by the 16. So you get 1 over 16. And remember, the standard form, the coefficient of that linear term, in this case y, is 4a. So 4a has to equal to 1 over 16. Solve for a, multiply through by 1/4 to eliminate the 4 here, and then the other side multiplying by 1/4 gives me 1 over 64. And of course the a value is going to be used to determine your foci and the directrix. And the focus, and of course because it's a vertical parabola, we add the value of c, or a I should say, to the y component, which is 0. So it's 1 over 64. The directrix will be horizontal. So this is going to be y equal to 1 over 64. So this one is in the general form. So we have to go through and complete the square. Notice it has 2 square terms, but neither one has a minus. So you don't expect to have a hyperbola. We haven't talked much about circles, at least in the last few videos. But if the coefficients, square terms, have positive coefficients and they're equal, in other words, if I make this coefficient of y squared also 4, then you expect a circle. In this case, we expect an ellipse. And I do want to point out, though, it's possible that the graph is not a conic at all. It could be just a point intersecting lines, called a degenerate conic. But here we do have actual conics. So we follow through with the procedure. I'm going to take the x squared term and the x squared together. So these I'll put those together, and I'll factor out of 4. So this is going to be x squared plus 2x. And then we have a y squared and a minus 4y. So y squared minus 4y is equal to, I'm going to take the 4 over to the other side, negative 4. So take those together, and these two terms come together. Y squared with y and the x squared with the x. Then I'm going to complete the square in here. Take half of the 2 and square it. That completes the square. So this will be x squared plus 2x plus 1. I'm adding 1 inside the parentheses there to complete the square. Now in the other one, I want to complete the square in y now, so I got y squared minus 4y. So again, the procedure is if the coefficient of the square term is a 1, I take half of the next term, would be the middle term, minus 2 and squared, I get 4. And that's equal to the negative 4 on the other side. But whatever I add to one side, to the other side. So here I put a 1 right here, but that's being multiplied by 4 times 1. So I'm actually adding 4 to the left side. So I have to put a plus 4 over here. In the same way, this one, no parentheses on this one, so here I just put a 4. That's okay, but I have to add it to the other side. So minus 4 and 4 cancel, I'm left with a 4. So now I got, this is a perfect square now, x squared plus 2x plus 1, that becomes x plus 1 times x plus 1 over x plus 1 squared. And then the y squared minus 4y plus 4, now that's a perfect square. The factors are minus y minus 2 times y minus 2 or y minus 2 squared. And that's equal to 4. Minus 4 and 4 cancel, leaves me with a 4. Okay, so now I want to write it in the standard form. I know I have an ellipse, so I divide through by 4. First term here gives me x plus 1, quantity squared. I divided by 4, so that 4 canceled out. I'll just put a 1 down here. Don't have to, but I'll just put it in there so you can see. And then the other one becomes y minus 2. quantity squared divided by 4. And 4 divided by 4 on the right side is 1. Now I have it in the standard form. And because of the form that I have, I know it's an ellipse. So from that information, I know the center is -1 and 2. And remember, for the ellipse, the larger number under these expressions is your a squared. So this is a squared. A squared is 4. And then over here, b squared is 1. And for the ellipse, we know that b squared is equal to a squared minus c squared. Or the same thing as saying c, taking the c squared over, minus c squared over, c squared is equal to a squared minus b squared. And a squared is 4, b squared is 1, so we get c squared is equal to 3, or we can say c is equal to plus or minus square root of 3. And again, because the larger number, or a squared, is under the expression with a y, we have a vertical ellipse. So the vertices will be obtained by taking the center and adding the a to the y value, or the 2. So a squared is equal to 4, so it tells me a is equal to 2. So we add 2 to the 2 here, we get 4, that's 1 vertex. And then we subtract 2 from the 2, we get 0. So we go -1 over for up, and -1 over, and we stay there at 0. Those are the vertices. For the foci, again, we're going to add the value of c to the y value, which is 2. So this one I'm just going to write foci at -1, and then we do plus or minus square root of 3. I do want to point out something to you before I end the video, and that's this. We've been talking about conics, parabolas, ellipses, hyperbolas, and for the most part they all have their axes or main axes either horizontal or parallel to one of the coordinate axes. But I do want to point out to you that there are other types of conics. They're not your standard conics. So far we've dealt with standard conics. But there are some parabolas that open this way, or open this way. Or there's some ellipses, instead of having a main axis, parallel to one of the coordinate axes, it might be at an angle like this. One example that I can give you, xy equal to 1. You look at that, what kind of a graph is that? Is that a conic? Doesn't have a squared term, no x squared, no y squared. And I can write it this way also, give you a different look at it, y equal to 1 over x. You would have graphed this. Notice it's not defined at 0. So the y-axis is a vertical asymptote. If I plot some points for this one, 1 and 1, I go over 2, it's 1/2, 3, it's 1/3. If I go over to 1/2 over here, it goes to 2. If I go to 1/3, it goes to 3. So as I get close to the y-axis, the value grows. So this graph kind of looks like this. I go through the negative side, Kind of looks like that. The axis for this particular one is not parallel to the y-axis or the x-axis. It's at an angle right here. This could be 45 degrees. So this is not a standard conic. Just wanted to throw that in just to let you know that they're not all standard conics like the ones we'll be looking at. Thanks for watching. See you next time.